and welcome to this Automation Academy Mastering the Machine video for July 1st, 2022. The topic today was Beckhoff and TwinCAT programming software. Hope you enjoy it. Hello everyone, and welcome to this, the 40th episode of Mastering the Machine. I've been doing these now since November of 2021. November of 2020. So this is the 40th episode. I just looked on my list, and today's topic is going to be Beckhoff and the TwinCAT programming system for Beckhoff controllers. What is Mastering the Machine itself? Kind of paying the bills here with my little ads. In 2013, I created a document called Mastering the Machine, and it's available for download at these websites right here. It is a step-by-step guide to planning, machine building, and documenting, which is the field that I've been in for most of my life, is machine building. So I wrote this document to kind of give people an inside look at how machine builders quote machines. And I thought the name was kind of cool, so I have evolved it into this webinar name. And I do these every couple of weeks, every 2 to 3 weeks, and I just title them Mastering the Machine. The Automation Academy itself is a training and automation website, have a lot of documents and things like that on it. If you want to check it out, you can see a little bit of a preview here and join for the low price of only $9.99 a month. What's on the Automation Academy? Have a lot of training videos. Don't have any on Beckhoff, but I have quite a few on Allen Bradley, Siemens, and Omron. A big part of my life involves teaching these platforms. So also have some job and aptitude assistance, systems integration. There is a big library of training documents, of which one will be this Beckhoff document that I'm going to be showing you, that I've done some research on. There is a community with interest groups on it. It was kind of a social media site at one point, but I have taken most of the profile stuff off of it. It just has some groups, and we do these regular events, Mastering the Machine webinars every 2 to 3 weeks, supported by the Automation Academy. So today's topic is the Beckhoff PLC platform, which is really it's a computer-based PLC. So that's a little bit unusual. It's not like your standard dedicated processors like Allen Bradley and Siemens. How did I get into this? Some people know I do 2 weeks every month for Automation NTH. My title there is lead trainer. I've taught their interns a few times a year. I have a 1 week long class on advanced PLC programming techniques. And recently, actually back in November, started doing 2 weeks a month for them, developing curriculum for them. I encourage everybody to go to Automation NTH's website and see what they do. They have a very interesting business model. They're not machine builders, but they are basically an engineering firm that does mostly controls engineering. But as part of that, they partner with machine builders and build a lot of machines for the life sciences industry. And since I do a lot of work for them, I kind of consider them a sponsor of this site. They kind of know what I do here, and some of the people tune in and check out some of the webinars on YouTube after work. And part of this, part of what they have at Automation NTH is a program called NTH University. NTH University is for interns or apprentices that they intend to eventually hire. And what they do is they put them through a pretty intensive 4-month program where they learn how to, do schematic drawings, things like that. Most of the people that are in the program are college graduates from local universities, usually Tennessee Tech, MTSU, a lot of them are from there, University of Tennessee. Some come from farther away, but of course it's easier if you live close by to take the apprenticeship or the internship program. But as part of their internship, they do a capstone project. And the capstone project, you can see some of these enclosures back here. During the internship, they program these, you can kind of see these little conveyors in the background, and they start out with RS Logix 500, which is an Allen Bradley program, and they make these conveyors work with little reject mechanisms and kind of a fake inspection of a part. And then they move on to ControlLogix, and they do the same thing. And they also program an HMI with that. You can see HMIs on the front of all these. And they use standard Allen Bradley equipment to do that, because most of the work that Automation NTH does is using the ControlLogix platform. And I've kind of documented this in some of the other webinars if you want to check that out. But at the end of their internship, they have a capstone project and they get assigned a different PLC platform. So you can see here, somebody did a PILS trainer. This is in their old facility in about 2017. I had this picture. They're in a new place now, and they have a bigger lab with some robots and things like that in it also. And then one of the students in 2018 got assigned a Beckhoff platform. So I went in and I checked that out and looked at the panel and what this student had done in there. And there wasn't a ton of documentation on the platform itself. Of course, he documented his project and wrote some of the issues that he had learning how to program on the platform using TwinCAT. But that was all I really had to go by when I was asked to create some documentation on the Beckhoff platform by Automation NTH. So a couple of weeks ago, this happened. They have a new business development guy, and he really wanted to explore the idea of eventually giving Beckhoff training to some of their customers. And for me, I was a little bit uncomfortable with doing that. Let me check. I'm getting a message here. Okay, well, it's not a message pertaining to this webinar, so I'm going to ignore it. But anyway, he asked me to do some research on the Beckhoff platform and asked if I was able to teach Beckhoff classes. And I am really not. I don't have a lot of experience with Beckhoff, but I said I would start investigating it. And I started out by writing a platform description, kind of what is Beckhoff, how does it work, what is the software, what is the hardware, that sort of thing. And I'm going to be showing you a bit of that, some of the things that I found out in the last couple of weeks. And connected with that, a few years ago in 2018, when I had my old facility, when I built this mini factory, of course, I put an Allen Bradley controller on it, and you can't see it, but over here to the left is a Siemens Step 7 controller. And they both ran this factory here, right? It had a dial table and it had some machine vision on it, had an HMI. The HMI could talk to either one of these platforms. All you had to do was disconnect these cables and they would connect to either the Allen Bradley or the Siemens PLC, and then it would run this little factory. And I use this for teaching classes and that sort of thing. But as you can see here, I had a Beckhoff controller mounted to the backplane way back here in the back. So I bought this back in 2018, and I fully intended to learn it. And I was really interested in the idea of using a PC for control here. So I bought this CX9020 controller and mounted it up and wired some of the cables into it and things so that I could connect it to this. But I really never got around to actually programming it or having any classes on it. I did investigate doing that, found a lot of resources, but there's quite a learning curve to learning the software. So I was not comfortable teaching this. So when Automation NTH asked me to look into teaching this, I said, you know, honestly, it takes a year or so of experience of solid work on learning the platform, and I'm not comfortable doing that. But I did start doing anyway this write-up on the material. So let me show you a little bit of the write-up. By the way, this trainer that you see here to the right, this lab, some of you know this who watched me before, a tornado came through and destroyed this lab, right? Went right through the middle of my building. And I was able to rescue a lot of the stuff in the lab. Unfortunately, some things like these conveyors and some of the toys that were on here did not survive, but the PLCs did survive intact. So what I did is I took the Beckhoff trainer and I built it onto this backplane. And if you can see right behind me, that is that trainer. So I use this to look into the software and learn what it took to get online and program with it. So a little bit about the document that I've written up. This is the document. This is the Word version of the document. And I have turned this into a document that I've put on the Automation Academy site. So this is downloadable. There are 144 different documents currently on the Automation Academy site. And this is the first on Beckhoff. And so what did I learn as I did my investigations, right? Talked about the product areas, the hardware and the software a little bit, described EtherCAT, which is one of the features of Beckhoff. It's a communication protocol that they use for I/O and motion control and things like that. So far, this is a 23-page document. The first page doesn't count. It's kind of a cover sheet. I did a little bit of an overview on Beckhoff's history. Of course, how do I research this stuff? I go to their website and I look it up and I do, Wikipedia and look at their website and talk to people that I know that use it and that sort of thing. And I get this information. So most of this is available on their website, of course. So this is just an overview, a little bit of the history of the company. And their control technology is based on open PC and IT standards rather than proprietary software like Allen Bradley or Siemens. So it is an open platform based on Codesys, which there are a lot of posts, of course, online about Codesys. Product areas. So a big part of what they do, of course, is industrial PCs, since that's what it runs on. It doesn't run on a standard PLC. It runs on an industrial PLC like this one that you see here. So that's actually a Windows CE computer. And of course, you could put their software on your own PC and run it, but there's all kinds of other Microsoft things running on your PC, so you might not want to do that. And they recommend against doing that at Beckhoff. They say they sell industrial PCs themselves. If you want to put their software on an industrial PC, they recommend that you use theirs since it's optimized for the product. They also sell embedded PCs, and that's what this is behind me. It's not a standard industrial PC. This is an embedded PC. So it runs on Windows 7 CE, which I have heard that Microsoft may not be supporting CE anymore. That's caused some problems for Allen Bradley on their Panel View Pluses, I know. So we'll see what that turns into. But of course, Beckhoff has a lot of experience building their own PCs and putting their own software on them. So I'm sure it will continue on the same platform. So those can be mounted directly on DIN rail with connections for the bus terminals on the right side. And that's kind of what you see here, right? That's what the one that I've got is. It's got all the bus terminals on it. So this is a picture of the CX 120 that I've got. So that's modular I/O, and you can put safety modules on there. So you can run safety PLCs just like you do in Allen Bradley using the safety logic stuff. They also build a UPS into a lot of these processors. So if you do lose power, it's going to shut down safely. That's always been a concern of mine when I lose power to a PC. And so rather than having to put a separate UPS on it, there is a small one built into a lot of these that will make sure that you get a safe shutdown. The Fieldbus components includes bus couplers, and a lot of people in my field use those. For instance, even if you have an Allen Bradley PLC, people will buy a Beckhoff bus coupler and they'll put Beckhoff IO on it because it is a little bit faster and a little bit less expensive than the Allen Bradley equivalent products like the Flex IO and things like that. So people have used the bus couplers at JR Automation, which used to be Wright Industries, where I worked for a long time. But they didn't use the platform itself until more recently. And I'll be talking about that in a little bit here, some of the contacts that I've made that use Beckhoff. So the Fieldbus components, bus couplers, they have them for lots of different languages. Of course, if you're using Siemens, you might use Profibus or Profinet. If you were using Allen Bradley, you might use Ethernet IP or DeviceNet. And then the native language for Beckhoff is EtherCAT. And EtherCAT is a little bit faster and has less jitter. We're not going to get into an explanation of what jitter is right now, but as far as timing, that's a really important thing when you're doing communications with IO. It makes things very predictable and precise. So I talk about EtherCAT a little bit more later here. It's part of this write-up. By the way, this write-up is in the Automation Academy, and you will be able to upload it. I don't have the PDF actually on the site, but I will have it by, I would say, the end of today. So I do have a PDF version of this. Other things that Beckhoff makes that go really well with EtherCAT is drives. They make servo drives and servo motors and little transport systems like this, planetary gears, transport systems, linear motors, and something I'm going to show you that's pretty cool in a little bit. That's a kind of a pallet-based system. Software products include TwinCAT 2 and 3. TwinCAT 3 is the newer version. One person explained TwinCAT 2 to me in the same way that, for those of you who are familiar with Siemens, the old Step 7 was. Step 7 opened a whole lot of different modules to get things done, and that's apparently the way TwinCAT 2 ran. But they still have some hardware that only works with TwinCAT 2. I don't think everything can be upgraded to the TwinCAT 3 platform, but most of the newer stuff, most of the embedded PCs and things run on TwinCAT 3 now. That is the more modern platform, and it runs on Visual Studio. So you actually can install it over the top of Visual Studio, or if you install it without Visual Studio already installed on your computer, you will get a shell for the engineering platform. So TwinCAT itself consists of runtime systems. They execute programs in real time, and the development environment, which is the engineering version, runs on your PC or on the runtime PC. You can also do NC, which is numerical control, or computerized numerical control, CNC. Probably heard of a CNC machine before. You can run CNC on TwinCAT software on their processors. So multi-axis motion control, that's the basic idea behind it. And I don't know a lot about DIN 66025, but this is apparently a CNC type program. So they have some high level extensions, things like that. So you can have 64 axes of control with TwinCAT CNC, lots of spindles, and you can distribute it across 12 different CNC channels. And there are a library of PLC functions, including temperature control and hydraulic positioning, Modbus, all kinds of different things. EtherCAT itself, a little more about that. That is an acronym for Ethernet for Control Automation Technology. So there's a lot of CAT related things here, TwinCAT and EtherCAT, but it's a real-time protocol. It's very fast, and it is different from a lot of other industrial Ethernet solutions like Ethernet IP or Profinet. Usually they receive a frame and they interpret it and copy the data. In EtherCAT, they don't do that. They take the data that they need, and then they pass the telegram on through the device to the next device. So it's a little bit faster that way, and you can insert some input data and have it ride along during the run to the other platforms. That's kind of a neat thing. So it is faster than other industrial Ethernet protocols. And so there's a minimum offset of bit timing, and this is the jitter that I was talking about. So EtherCAT has little or no jitter. There is no such thing as no jitter. There are timing issues, but it's less than a microsecond of difference. That's a fluctuation of timing signals. Had to do a little research on that also. So hardware, that's where I did the write-up here on the hardware. Industrial PCs, already mentioned that. They're built in various configurations. It's just like a regular old PC, except it's been hardened for industry. So it's a little tougher, has solid state hard drives, things like that. And there are also some units that you can get that are built into the screen, right? A touch screen. And so they have multi-touch TFT formats from 15 to 24 inches. And also they have a slower or a smaller platform, and that was this one. What? Let me see if I can get that back. It's kind of trying to tile on me here. I didn't want it to do that. There we go. So this platform is a 7-inch panel PC, right? So this is an example of one of those multi-touch touchscreens that this student did on the Beckhoff trainer. So all the I/O and everything is controlled via EtherCAT out of the back of this. I have another picture of it if anybody ever wants it, but it's running a bus coupler inside of it with some of the same type of I/O that I have here, right? So this I/O can be stuck on a bus coupler or on the right of an embedded PC. Okay, back here. Wow, that tiling kind of messed me up there. So that is an example of the 7 or 10-inch smaller HMI panel PC. These use Cortex A8 processors, and I listed a lot of the different types of processors they use in this document. That can be a useful thing to know. I got most of this, as you would imagine, off of their website and kind of encapsulated into this document. The embedded PC products come with the control software, the runtime software already installed. That was the one that I showed you here that is mine, already had the runtime installed. So all I needed to do was create a program and download it into the runtime. And we'll talk a little bit more about the licensing and how that works later. But it pretty much, other than some communication problems, it worked pretty much first time when I downloaded the small program into my little demo unit. So that's pretty convenient. You already have all your software ready, and allows you to put some multifunction I/O, lots and lots of different kind of I/O. I'm about to list that here, show you some of the different things you can stick on the right side. The operating systems themselves, Windows 7 or 10 based, and Windows Embedded Compact 7, which is what I had, the CE, Windows CE, and you can get Embedded XP or .NET, CE.NET, depending on what type of unit you order. If CE.NET is used, the system is programmed with a laptop or desktop PC separately, and that's what I did for my embedded platform. The supply voltage is 24 volts. Everything is 24 volts, so you don't need to go 120 and you still need a power supply, obviously, to run I/O, but that's all you need, right? So that's what I did on my trainer here. I just put a 24 volt power supply. You can see it down there at the bottom, and it runs everything, all the I/O. By the way, if you're wondering what the black thing above it is, I needed a place to put my Keyence vision system, so I just mounted it to the same board. It doesn't have anything to do with the Beckhoff, right? But that's what's up at the top. So it has its own power supply too. A list of the bus couplers and protocols. So these are some of the protocols that you may already be familiar with, right? Profibus is Siemens. CANopen is kind of an open protocol. DeviceNet is mostly Allen Bradley. I've seen some of it on Omron. Ethernet IP, a lot of people use that. Profinet, that's again mostly Siemens. I think some Bosch controllers use it. And then all of a sudden you get into lots of different EtherCAT protocols. And this is the native Beckhoff protocol, but as with other protocols, other companies have made things that run on EtherCAT. So for instance, if you want a valve bank, you can go to Festo or SMC and they will have an EtherCAT version of valve bank. And a lot of different types of bus couplers here. These all start with EK for EtherCAT, right? And they put a K in there instead of a C, but all the extensions are EKs here for EtherCAT. And then all of a sudden you get down to some interfaces that allow you to go from Modbus and then go to EtherCAT across the backplane. So that's basically the way even this one works. This controller that I've got, the 9020, uses TCP/IP into the Ethernet port, but then across this backplane, everything is EtherCAT. And I could go out this port here on EtherCAT and connect to a bus coupler also running EtherCAT, so everything would be fast that way. A little bit faster than certainly TCP/IP would be, which is not something used for industrial protocols. So you can see all the bus couplers that they have listed here. And of course, you can find this on their website. Then they have some bus couplers that have PLCs built into them. And that's what the bus terminal controllers are. They're bus couplers with integrated PLC functionality. So you can download a program to them. They're like intelligent slaves. And you can kind of decentralize your system that way, kind of like a DCS, right? Just like having RTUs out in the field. So you can use the bus terminal controllers for that. The bus terminals themselves are these little terminal block type devices that you see here. Oh, there we go. You see a bunch of them here. So for instance, I've got 4 input modules here, and they're DC input modules, syncing only, right? They are, I think they have sourcing modules also, but these are syncing. And then I have 4 bus terminals here that are sourcing outputs. And then I have an analog input and an analog output. And I can stack more devices here to the right, and it builds the bus with little metal connectors along the side. So as you slide these in, this is much like this compact logic system here. You slide the cards in and they make contact by building their own backplane through the back of it. So that's what the bus terminals are. And you can see here, there's more than just inputs and outputs and analog. There are pulse width modulation outputs. There are watchdog terminals, right? You can monitor pulses coming from the controller and make sure that you still have communications. Some odd things here. I think the universal dimmer output, this I guess would be used for lighting. So I've heard that a local company here, Animax, uses a lot of the Beckhoff for their lighting control. And they do shows and things here in Nashville for some of the famous music people around here. Speed controllers for AC motors. So that's basically a small AC drive in this footprint, right? So you can slide a small drive right into that bus now, and you're not gonna be able to handle a ton of power with it, right? You don't have enough room for your IGBTs and things. High density digital outputs. These would be putting more digital outputs on a card than you would see here. Like I've only got 8. You can get into 16 or 32 outputs on a single card and slide that in there. You can see lots of analog here, single and dual channel. I've got more on wiring of single and dual channel circuits on my website. But you can see lots of different types of analog. The thing they call accurate terminals here are basically 16-bit analog. You got PT100 RTD type inputs, 3-wired resistance devices like load cells and things like that. More RTD stuff here, thermocouples, resistance bridges, power measurement terminals. So if you want to do power monitoring in your plant, you can do that and run 480 into the card. And continued SSI sensor interfaces. There is IO Link right down here. So Automation NTH uses a lot of IO Link. That's an intelligent sensor platform. OSI, right? So this is used often on robotics, things like that. And then there are all kinds of serial interfaces, RS-232C, TTY, 485. even this N-Ocean, which I'm going to talk about a guy here that's a very good resource that did some projects, I think, using this N-Ocean platform. So one of the things I'm going to have to do, you can see here, I've got a small touchscreen, and this is a serial only touchscreen. And this, I'm going to have to figure out what kind of a driver I want to use for this. And it's possible I could come out one of these USB ports and connect up to it, but I may have to get one of these bus terminals here and use RS-232 or 485 into that touchscreen. If that's so, I need to figure out what protocol I would need to talk to a WineView touchscreen. But they have just about any kind of terminal that you can think of here. There is something called a K-bus or an E-bus. I believe the E-bus is the fast one, and the K-bus may be a little bit slower. I don't know a lot about that. You would have to look that up, but that's what these extensions are for. You can expand these out, right, and run a separate controller off the end of this. Surge filter terminals, buffer capacitor terminals. Then there are things like these modules, which have plugs on the front of them, modular units with plug-in connectors, just higher density. We talked a little bit about that up here. So they have a pretty huge range of products here, including 16, 32, and even 64 channel densities that you can plug right into the front here and then bring out to an expansion terminal block. Bus modules. They are box modules. They call these boxes, right? If you try to add these to your network, and these are similar to some of the Wagos or Phoenixes that you've seen, right? You can basically daisy chain these together using EtherCAT or IO-Link or Profibus or whatever you want to use. And so a lot of machine manufacturers may use something like Ethernet IP, but put Beckhoff's modules on their machinery. Right, and the cost is pretty good, and they have such a wide range of products that's why people might do that. Most of the things that you saw up here in this list that I listed here are also available in the box modules, and then I found some things that were extra, right? So you can be an IO-Link master with one of these. And I know that Automation NTH uses a IO-Link master in the bottom of the machine that I documented in my book. You can put accelerometer boxes here, right? You can have a box that does nothing but take accelerometer inputs, stepper motor modules, pressure inputs or load cell resistor bridges, right, for weighing things or doing pressure monitoring, angle and position measurement, so encoder inputs basically. Servo motor module, you can have an entire servo motor module in this kind of form factor, communicating usually EtherCAT back to the Beckhoff controller, and even a brake chopper, right? That would kind of do like vector control on drives. EtherCAT terminals also come in the same types that I listed there in the bus terminal list. And again, I'm getting all this straight from their website. I just kind of digested it here. For those of you who don't know what NMUR is, NMUR digital inputs are intrinsic safety. If you've ever dealt with intrinsically safe IO, that's for explosive environments, and it keeps the voltages under 8 volts. Right, because sparks will make things explode, and this prevents sparking if you stay under about 8 volts. So it's kind of safety for explosive environments. Digital IO with a timestamp for critical applications. 4-channel LED outputs or LED strobe outputs. This would be for like vision systems, which I'm working on a vision system right now. I may have to look into that for doing some strobing of lighting. It may be a less expensive option than buying a lighting controller. The license key terminal. So we'll talk a little more about licensing later, but your other option would be to download the license into the controller. And then of course, if you went and connected to a different controller, you wouldn't be able to move it easily. So you can actually put a module in here that has the license key on it, and then move it to a different unit. And of course, you could also plug it into the USB port here. There is a way to do that. A memory terminal. So you can actually put a terminal just kind of like this with memory in it. That's very interesting too. Light bus, not really familiar with what that is. I assume it has to do with lighting, but I don't really know. Interbus is something used by some European systems. So you can use different protocols into that. You can have a master slave for Ethernet IP. This would be Allen Bradley. Master slave for Profibus, that would be mostly Siemens. CAN open. Somebody asked me recently if I knew anything about CAN open, and I really don't. Haven't done any programming with it, but it is another open protocol. So probably people who do code assist would use CAN open, I believe, for their communications. That's a common thing to do. Not sure, again, what DMX is, but you can have a master slave for that. Now, BACnet, I have done some work with. That is a building controller. So building control software uses a communication protocol called BACnet to control things like louvers on air handling units, or just building control type things, security or whatever. A 4-axis interface, so you can do multi-axis motion control with one of their terminals here also. Now, this I thought was interesting. This is a simple version of this, but a plug-in module. This is a backplane where you can put couplers and plugs to distribute all your communication to different types of terminals. And so you can see all the plugs here, and these would go to other units. And then there is a diagram of this complex thing down here that you can plug all kind of different modules in and come out on cables to other units. And this would be for people that build proprietary equipment, or sometimes they call it OEM equipment. If you have something that is, let's say, a building controller, and you wanted to build it and commercialize it and brand it yourself, Beckhoff would actually get with you and help you put together a custom board like this to do all the control for you, right? So it would be proprietary, and they'll even brand it with your name on it, right? They may put Beckhoff's name on here also somewhere, but you could have your own controller with your own layout. So this is a more complex system. And let's see, distribute signals and power supplies, pre-assembled cable harnesses, avoid the need for connections of individual wires, and you can have coded components, kind of a poke-yoke, to make sure that only certain cables plug into certain ports. And they do standard units like this one shown, but also they will do customization as an engineering service. So you can develop your own signal distribution board based on a design guide. That's kind of neat. Fieldbus cards, these are all communication cards. EtherCAT, we've already talked about. That is their very fast IO system communications. Again, not sure what light bus is. I'll have to look that up. It may be for lighting. It may be some proprietary thing for somebody else. CAN open, again, my guess is that the standard code assist platforms may use CAN open because it's an open platform. Circos is used for motion control. This is what Allen Bradley used to use, fiber optic control to multiple drives and things. And so they still support that. And then, of course, you can have various Ethernet protocols, including TCP/IP or EtherCAT, or the previously mentioned Ethernet IP or Profinet. Fieldbus switches, you can get switches not only for TCP/IP and things, but also for EtherCAT or anything else pretty much as far as communications. They had a long list of switches, and that would be just kind of like your Ethernet switches, where you would bus things out and it probably reconstructs the system and sends it out. Drive technology, servo drives are huge. You can see here, there's an example of a multi-axis drive with some motors. There's a single axis drive. You can get brake modules, chokes, filters for VFD type equipment, and you can get distributed servo drives or integrated servo drives. That would have the motor and the controller built into the same unit like this. So I put a picture of those. This is like, I used to do some work with something called animatics, and it had a drive and a motor built into the same unit. It was pretty nice because you could just supply power and network communications to them and put them on your machine. And it was a lot less cabling and power control, a lot less space in your cabinet to do that. You can buy regular old rotary servo motors, just like you've seen on anybody else's platform, just like Alan Bradley or anybody has. You can buy stepper motors. I look through these AM 8000, 8500. They're just typical servos with encoders built into them. Stepper motors are for the pulse outputs. You can get stepper motors directly from Beckhoff. Linear servos, right? So a lot of people use linear technology for linear motors and things. And kind of related to that is this X-planar system. Now, this is not a linear motor module, but what this does is it has these little tiles and pallets, and you can take the tiles, and the tiles will magnetically turn these pallets, right? Rotate them or move them left or right, or even levitate them off of the surface. So that's kind of a neat thing for transport. So it moves, it raises and lowers, it moves left and right, and it rotates. So it has apparently said 6 degrees of movement. You can even tilt these. Now, I'm not sure why you would want to necessarily do that, but you can tilt the tiles also, or not the tiles, but the movers, which is the pallets. So X-planar system. So I'm going to talk about a resource that I found. I've talked to this guy, Jacob, and he has if you join his YouTube channel and give him a little bit of support, he has some kind of secret videos, right? That he explains how all this works, and he has some video of this actually working, which is pretty neat. And he does a lot of programming on this platform. I invited him to show up today, but I don't see him here, but he's in Germany, so it's late Friday there, so he may not have been able to show up. Software itself. So we're going to get into that. The name of the software is TwinCAT. And again, there are 2 versions of it, as I mentioned before, TwinCAT 2 and TwinCAT 3. The older products were TwinCAT 2. And I did ask some people about why do they still support TwinCAT 2? And I was just told that certain products, some of the older products, they never converted to support for TwinCAT 3. So it still only programs in TwinCAT 2. Both packages, TwinCAT 2 and 3, use Codesys as a background for it, and Microsoft Visual Studio as the actual installable platform. So the architecture is called XA, Extended Automation, and they further classify it as the engineering package, which is where you do your programming, and then the runtime package, so XAR. So a lot of their acronyms will have XAE or XAR in them, and you can count on the fact that that has to do with either writing your program or the runtime that runs on the embedded PC or on the bus coupler or whatever. So when you install it, it uses Visual Studio, and if you already have Visual Studio installed, it's going to install right over the top of your existing Visual Studio. Now, this can cause a problem. I had somebody do this at Automation NTH, and it kind of co-opted a lot of their extensions for previous products, and it tried to open them in TwinCAT, and he didn't like that. So he had to uninstall the software. And I'll talk about some of the adventures that I've had with the installations and other people installing it at NTH in a few minutes here. So it could still be useful, right? Because if you integrate it with Visual Studio, you can do things like program in C instead of just the IEC 61131 languages, as I mentioned down here, which are your typical PLC programming languages. If you want to add C, C#, something like that, then you would want to install Visual Studio first and then install TwinCAT over the top of Visual Studio. And that's what I did. Since I didn't have anything that was critical, I went ahead and installed Visual Studio 2017 because I haven't found out whether the later platforms are supported. I imagine they are, but I was a little bit afraid to try. So I could have installed, 2021, but then if it didn't work with my TwinCAT, it would have been kind of a waste. All of the IEC programming languages are available. Most of the people who will watch this already know what those are, but those are things like ladder and function block diagram and SFC programming, things like that. So all those languages are supported. I have only done so far structured text on my unit because that was the tutorial. So ladder is my more native language. So I do plan on doing some ladder to blink some lights and things. We'll see how that works as I move through my own adventure here. So here is a little bit about integration into Visual Studio. If there's already a version on your engineering PC, but no full version, then the extensions will be installed, but your front end will be, you will have a choice as it turns out. You can either open up the XAE shell, TCXAE shell, or you can open it in Visual Studio. You have that choice. Now, I didn't ask the guy who had the problem with it installing it over the top, whether he opened it in the shell or if he opened it in Visual Studio. He had Visual Studio 2019 installed, and he did have it kind of take over some of his projects. So it could be a problem. So that's a little bit, if Visual Studio is not installed, it's going to automatically install the shell. If you already have a version of it, but not a full version, the extensions will be installed, right? And the functional range will still do the same thing here, only with your 61.131 languages. But if you have a full version, which is what I did, the extensions will be integrated into the existing Visual Studio. And these are the other things you can do: C, C++, MATLAB, Simulink. You can program using those languages also. And of course, since it's a computer, you can write other programs in Visual Studio and download them into the computer and have them do whatever you need them to do. So I've heard that you can do things like Node-RED or other languages in the Beckhoff controllers, but you would have to have probably an industrial PC to do that. I'm not sure you could do that with the embedded PC, because so far everything I've found here says you're downloading from Visual Studio, you're just downloading these languages, right? C, C++, or MATLAB. The runtime itself, so real-time environment, TwinCAT modules can be loaded, executed, or administrated. So when you do your little tutorial application or something, that's what you're downloading into. And as I mentioned, this was already installed on mine, so I didn't have to go through the installation of the runtime. But you can get a runtime from them and install it on your own PC. Or, of course, you could run the runtime on your development PC. And you do get access to a 7-day license that you can renew eternally, right? Just keep renewing it. That's kind of what I'm doing right now. I have this hardware, but I have just a free license, and I have to renew it every 7 days. But I could also buy a license, and if I bought the license, then it would run permanently. I wouldn't need to renew anything. What other things do I have? Generally, generated modules are called cyclically, just like a regular PLC, right? So it does them in a row from whatever your tasks are. Several tasks can be run on one control PLC, just like, for instance, Allen Bradley. So you could have a cyclic task and some periodic tasks, and maybe some event-driven tasks. And these modules, right, the SPS, C, or C++, can call themselves in the runtime. So lots of different possibilities for software architecture. Number of modules that can be called from one task, theoretically unlimited, as long as you have enough memory to host everything. If code execution takes too long, though, you will get a watchdog timer warning. They call it cyclic exceedings, but it just takes too long to execute based on having too much code or taking too long to execute things. So much the same as a regular PLC. Here is a little bit about the transport layer for TwinCAT, right? How everything communicates. You can have a PLC running here, a C++ module running here. You could run numerical control or CNC. Not sure why it's grayed out. And maybe they just are kind of calling your attention that all the PLC or control type stuff is running here in green, right? A C module, C++ module, Simulink, and then the CNCs are gray, and then your safety stuff here, right, could be a separate task. You have function block diagram here running safety here. So lots of different ways to control this. This is all the device drivers and everything, just a picture of it. Again, I got this straight off of their website. It's one of their diagrams. And there's the Fieldbus out communicating to all of the IO. And then there's the run times. You could be running them on different cores. So you can use multi-core processors. And most of the processors, I think the one that I've got here probably has 4 cores on it. And so it could run a different task on every core, doing a different thing. You could run the HMI on one of them. You could run a runtime on one of them and a different runtime on a different one. And then you use this ADS to communicate to all your IO. And that's what this diagram is showing here. And then you would have EtherCAT, in this case, ADS routers. That's automated device services or something like that. I forget what the acronym stands for. Product classes. So that's an interesting thing also here. You have lots of different categories of things, system-based stuff, which is just the computer, HMIs, measurement units. When you open the software, you actually have a choice of creating a PLC project or a measurement project. So this is used extensively for measurement of things. Motion control, you could have things just doing connectivity and converting one language to another. And then there are also hardware categories. And this is very important if you order your license, because your license will support up to a certain level. So for instance, if I want to do a, let's see here, ARM Cortex, this is what I'm running. I believe it's the Economy Plus. So my CX9020 runs on this level. So I would have to buy at least this level license to run on that. And then if I wanted to do things like some of their higher level controllers here, you can see these are the regular computers here, Intels and Celerons, Pentiums, things like that. I would need to have a P50 performance level, so a higher level license. So I have not bought a license yet, partly for that reason, because I don't know if I'm going to need to run this at a higher level later. I'm going to use a little bit of input from Automation NTH to determine that. But right now, I only need this. So that would run this controller that you see behind me here. That's what I would need to run that. And you can see here some pictures of some big servers and things. Xeon processor here, server doing major control here. So P90, P81, that's their highest levels, very high performance or other. And they run on server-based systems. So you might be able to run a whole plant on something like this. So pricing for that software is based on that level of capability. So you're going to pay more for the more powerful licenses. So of course I need to get a quote before I decide, do I want to get something like a level 5 license that would run on, one of my PCs or on my server or something. I would need probably at least this level of licensing. A little more on XAE, which is the engineering. It's an extension of Visual Studio. So for instance, I've got it installed on this computer, and down at the bottom, I don't know if you can see this, but if I open this up, this is access to my TwinCAT software. I can open it in the program itself also, but it's running on this laptop. So you can run it on Windows 7, Windows 10. Haven't heard anything about Windows 11 yet, but I imagine that soon after Windows 11 comes out, I would be able to run it on that also. Hardware, they recommend this on the development computer, at least 1.8 gigahertz, main memory, at least 2 gig of RAM, not uncommon anymore. And let's see, I have a misspelling here. So at least 2.5 gigabyte if running on a virtual machine. Hard drive space, you need at least 10 gig of available memory if it's not been installed, right? Because you're going to be installing part of Visual Studio, even if you simply install their software. Hard drive, they recommend a solid state drive. Graphic card, they want a good graphic card also. XAR, so the runtime itself, again, they recommend that you buy their industrial PCs, or you can get one of their controllers here running on the embedded PC, but it will run on all these platforms. You can use embedded standard 2009, and that will go up to 4022. Now, my software is 4024, and I'm running this on 4020. I'm going to talk about that in a few minutes here. What is the difference between those? Beckhoff embedded PC with TwinCAT 3 image, that's what I've got, and I'm running Compact 7, right? So it's Windows 7 CE and 500 meg free memory space. I think this controller I've got probably only has about 500 and some meg, like 512 it lists on it, and then I'm not sure what the RAM is. And it gives this little warning here. I'm not really sure what Hyper-V is. It's a virtual machine of some kind of like VMware, but you can't run the runtime on Hyper-V, and it goes out and tries to detect whether that's what you're trying to do, and it will disable it. And that may be because it's a way of bypassing their license. So they have kind of disabled that, and it just says flawless real-time behavior cannot be guaranteed if the runtime is installed on a third-party PLC. Or PC. So they want you to install it on one that you buy from them. So licensing, generally it's done through a dongle, right? So you would get a little USB stick dongle. You can get the license key, and then you can move it from place to place. I can configure it once. I can plug it into, I believe, this port here, and then transfer it into this controller, or I can leave it on my PC. But once I disconnect my PC, if I haven't put it in here, then that 7-day license would expire after 7 days, and I would have to plug the dongle in anyway. So that could be a downside here. You need to renew that on one or the other every 7 days. You won't be able to use your engineering and your runtime at the same time if you only have one license. Easiest way to order a licensed dongle is just with a pre-activated license. They no longer have to be activated by yourself. Allen Bradley, for instance, you have to go to their website to activate it. That's pretty much the way all their stuff works now. And then I have a lot of other stuff here on the licensing. You probably don't need most of this, and it's on your website, their website anyway. But I did put some more information. You can order multiple licenses. Let's say you've got a bunch of these HMI type units that I showed you. You would need one license for each HMI type unit that you had. And I think that's probably the really low level is the HMI type units. So a little bit on that. Identical licenses that don't contain any instances may not be listed several times, etc. I don't know what else I've got here. Beckhoff discussions. Okay, so this is interesting. We're actually coming kind of to the end of our time, but these are some of the people that I talked to when I put out a call for information on Beckhoff, who is using Beckhoff, right, in industry. Elton, we had a bunch of back and forth. We actually connected on WhatsApp, and he has a friend who works as a support engineer for Beckhoff, but he lives in Brazil. And he does a lot of Allen Bradley and Siemens like I do, but occasionally uses Beckhoff. And he went to a training course, and then he did a couple applications for him. He has some of the training presentations. So he offered to, let me have those, but they're in Portuguese, so I wouldn't have understood them. His general evaluation: if you need to build your solution from scratch in Beckhoff, you'll have the hardware and tools, but not the knowledge, right? So that takes practice, and I'm finding that out myself. Everything that's not online is weak or lower than expected. In other words, even though he has a friend that is a support guy, he doesn't get a ton of after-sales support. That is indeed what I'm finding. Was able to get a guy to help me from Minneapolis, but the local guy here is not really an expert at the software, so couldn't go very far at helping me with some of the problems I had. Some of the machinery worked on, he said, complex and precise, right? He's worked with some nice machinery, complex and precise. They have an amazing product for motion control, as I showed you with some of those tiles and movers and things. in terms of speed, accuracy, and reliability. And that's what I'm finding when I do research on it. I asked him about TwinCAT 2. He said it's the old version based on CodeSys version 2 rather than version 3. And it's like Semantic Manager, different approach, different licensing methods. The license was kept on the processor in some cases, and it uses the processor cores differently. Doesn't work with recent products. So that was an important distinction there. The current programming tool is TwinCAT 3, better than TwinCAT 2. That's all I've used so far is TwinCAT 3. And everything's integrated together in the same environment, just like Siemens TIA. So that was a big change for Siemens. Semantic, I could have 7 or 8 windows, separate windows open when working with step 7. And he said, it sounds like TwinCAT 2 is the same, where you'd have multiple things. You might have one open for your editor, and another one open for your communications, and another one open for different modules or monitoring, things like that. So everything's all self-contained now. Jack Davies, there is another guy who I contacted, and he connected me with his technical manager. And we were going to have a discussion, but we haven't gotten around to it yet. This next contact is probably the most important one that I found here, other than a guy named Dustin Hullett, who works close here and knows a lot about TwinCAT. I haven't really talked to him yet, but Jacob has a YouTube channel, and he does a bunch of free online tutorials for TwinCAT 3. He's a German guy, so of course English is not his native language, but he does a really good job on his YouTube channel. And he's also posted some things here, alltwincat.com. This is his website. And he has a post here called the 5 Best and Worst Things with TwinCAT. And he's worked on a lot of large Beckhoff systems. So I kind of put some of his technical background here. Core Power Ocean. So that N-Ocean platform, I think, had something to do with this. Design, implementation, and testing of control software of the half-scale wave energy converter deployed by the Orkney Islands. I should probably say on the Orkney Islands. And it was created using TwinCAT 3. So he's definitely an expert at this. He doesn't work for Beckhoff, but uses a lot of TwinCAT. Let's see, general evaluation. He said, I'd say I've encountered Beckhoff in every possible industry and application. Of course, he's from Germany, so he's going to see a lot more of it than we do. One application was really cool. They used it at 3,000 meters in a telescope. So that's pretty cool. Most of the users use structured text. I asked him specifically about ladder. Do people use ladder much on it? Because that's what we use a lot more here in the States. But he said most people have used structured text because it's based on CodeSys. The graphical languages implementation is really good. That would include SFC and ladder. And he said, I have to say pass on TwinCAT 2, as I haven't seen it in the field for a very long time. And they put a lot of effort in the tool to convert TC2 to TC3. Most he's seen have converted TC2 into TwinCAT 3. But I know there is still some hardware that only runs on 2. Other jobs he worked on, there's that observatory that he worked on. Also implemented various supporting software, .NET C# program to configure all 132 PLCs during manufacturing to simultaneously, and I don't know what this is, M1P DCU PLC software for all of them. And this is going in South America, I believe. DP patterning, responsible for design, implementation, and testing of the control for the DPP 360 machine. Lots of machine vision on that and motion control. Andrew is a guy I knew at Tesla. I had him in a class before, and he said he did full machine control, and it was all structured text at Tesla, used to run motion control with LTI servo drives. So that's proprietary stuff for them. He used a Keyence XGX interface, which, as you can see, is what I've got here. So I'm eager to combine those two myself, connect them together on Ethernet, and get some information back and forth. Also used Beckhoff IO and Safety PLC. Then I put the references here, and we are kind of toward the end of the webinar here. So I'm going to show you a little bit about these references. The Beckhoff information system is, so this is LinkedIn, I was monitoring that, is this. So infosys.beckhoff.com. You'll find pretty much everything that I found to create this document, right? Here's everything about TwinCAT 3, and you drill deeper and deeper on this, and you will find all kinds of things. You will find the hardware platforms, the software platforms. There's all the industrial PCs, there's the embedded PCs. So as you're doing research on things, you would go to this Beckhoff information system and drill down to whatever you needed, and you could get even wiring information right here off of this Beckhoff information system. Let's see, I had something else that I was going to show. I have one more slide here actually, and I've got some references on that if I can find it. Here we go. So this is some other references for you. This is what I found on YouTube. And the best one that I found, the most commonly used, was Jacob's site. And he has a support mechanism by which you can join his, and you will get some proprietary stuff, right? You join up, you can become a coffee provider. And at the low price of $3 a month, I signed up for that, and you get more videos. He's created a ton of videos on YouTube that are tutorials. And since NTH is letting me do all this research and everything, I went ahead and signed up, and I'm using some of his videos to write some of my own code. Of course, some of the other usual suspect, RealPars, they have things on all kind of different platforms. I did find some videos from them on Beckhoff. Electrical Automation Hands-On also found that, and a guy named Squishy Brained, and that was kind of interesting. All these are on YouTube. So these are just some other resources that are out there, but I would definitely highly recommend Jacob's platform. And I did get to talk to him a little bit on LinkedIn. You could probably connect with him there, but so far the best tutorials I found were there. And I mentioned again here this Infosys up at the top, because that really is your main resource for Beckhoff platforms. Beckhoff also has a tutorial. I have it on my NTH computer, but was unable to find it by searching online. So that's rather interesting. I don't remember the name of the website, but it was not under My Beckhoff, right? My Beckhoff is the, if I log into Beckhoff, that's what I get, is My Beckhoff, right? Let's see here. If I sign in to regular Beckhoff, I get this. Right, My Beckhoff, and I believe this is how I got to their tutorial, but I've been unable to find it from here. And I do know it takes a separate login, right? It has a different password than the My Beckhoff does, but the training is available also through Beckhoff. So I went through that tutorial when I built my own system. So far, I've gotten through all the hardware setup, and I put a simple program, and I have started writing another document. And the biggest problems that I found so far with Beckhoff, the programming environment wasn't too bad. Installation was fairly straightforward, but I had a lot of problems with communications. And so a few things to be aware of. One, if you want to communicate to a different firmware version, you're going to have to install something called the remote manager. And this was not intuitive at the beginning. And, you know, us guys, we don't like reading directions here, but you have to first install the remote manager. And then anytime you enter the programming environment before you open your project, and I kind of mentioned that here, if you select the wrong version, and the default is 4024, right? That's the newest version. You will have to close all the Visual Studio and reopen it after you've selected this. So you select build 4020, then open the project, right? And then you will be able to program and download, or do what they call activate configurations, which is basically the download. So I've started, you know, explaining all this and how you download and go online and all that kind of stuff, editing routes. But this was one of the problems that I had. So it's not enough to simply put your IP address in here and try to connect. You have to build this, establish a route, right? Edit routes. And when I did that, I never got my little X here. I had a lot of problems getting this X. So this was the stuff that I had to connect to the guy up in Minnesota to ask him what the problem was. And we went through all the typical things, you know, you have the right mask and connection. And I said, well, yeah, because I pulled all this up and I got all this information from the controller, but it wouldn't say it was connected and it wouldn't establish the route. One of the things he told me that is nowhere in the documentation is he said, go in and delete this file. And this is not intuitive, right? Go into C:/TwinCAT 3.1 target, delete the static routes and add it again. And that cleared the cache and it did work the first time I did it. But then I came in the next day and tried to connect and the little X was gone and I had to do it again. And it was not at all intuitive to do that. So that might have had something to do with the firewall or, you know, but I had to completely reboot, rebuild the route every time I went online with the unit. And so this is another document, right? This one I will have on the website, on the Automation Academy site, probably this afternoon or tomorrow. This one is a work in progress. So I'm doing a lot of work for Automation NTH on this. So this is a Beckhoff programming document, and then I'll turn it into something that I can put on the Automation Academy. In any case, let's see. We'll go back to this. Whoops. Somehow I'm switching screens. Let's get back to my shared screen. So that was all the resources, and we'll go ahead and wrap this up. Losing control of my screen here. The next webinar, probably July 15th. That is the week before I go to Las Vegas to teach a control logics class. Unknown topic. There's a good chance it's going to be Cognex. I am still working on my little unit in the other room here. I have my DC lights working. I'm getting a good image and I'm able to automatically trigger my PLC. So by the time the next webinar rolls around, I might be able to do a good live demonstration of the Cognex spreadsheet software and how all that works. Or I see Phil lurking here. Maybe Phil can come hang out and we'll just shoot the breeze for an hour. But we'll see. In any case, the next webinar will be July 15th on an unknown topic. Any questions from anybody? I see Phil here. How you doing, Phil?
Hey, Frank. I've got a question on some of the IO link modules that you were showing.
Yep.
What did you call those again? There was a term. They were like blocks or.
Yep. Let me bring where was that? That was here. Beckhoff Platform. Yes. So I don't have all memorized too. Yeah. On the hardware.
I was just thinking of the proper terminology to refer to them in the future.
Right. And there is a lot there to learn. So many different types of units.
The other interesting thing was the vibration. I'm a little bit curious if they're just providing IO links vibration sensors that are providing some pre-calculated features.
I don't think so. Yeah,
or
they may
if they
have
were providing.
Yeah, they may have
some additional.
The IO link terminal, that was an EtherCAT terminal, right? So that's a not a bus terminal, right? But they had IO link there, and I believe they also had it here, which was an IO link master. So the EtherCAT terminals, you can get an EtherCAT terminal that would go in the rack and go out on IO link, right? And then you can also get one of these. And this would be a box. That's what they call them, box modules. That would be an on-machine solution, and it would be an IO link master.
Yep.
And then you can see the vibration monitoring that they had was it was a separate unit, and it didn't mention IO link. So
oh, okay.
Yeah, so that was one of these, I believe. I think the vibration monitors was a bus, one of the bus terminals. Let me see. Okay, bus.
Interesting. I'll have to look into that a little bit deeper.
Yeah, there are hundreds. I mean, I listed most of the kind of the categories here. Let me Single channel.
Oh, yeah.
Vibration monitor. So what these did is I started listing the things, and then you know, I would be on these link modules, and then I went to the bus terminals. And I said, well, this has everything that the link modules has plus these things. So bus terminals continued. I think the vibration was somewhere in here. Where is it? In Ocean. I thought it was in here. See, a oscilloscope. That's interesting. Just a little module that's in an oscilloscope. I thought the vibration was in here.
Wow. Okay. And so these are all the Beckhoff modules that
Yes.
would
Yes.
go into
So best place to find it is that Beckhoff information system website. You know, so that's way down here at the bottom. But if you go on that and you drill down, you'll find everything about everything.
Great. Fantastic.
Yeah, right. There. Yeah, infosys.beckhoff.com. And that you don't have to be a My Beckhoff membership to go to. You can just go straight to it without registering, and it opens everything up. But that's everything, all the hardware and software and everything you would need. All the manuals are accessible there and everything. So, yeah.
Fantastic.
The search has been pretty good. But for instance, I was not able to find the tutorial that I'd signed up for. And I went through all their tutorials on configuration. And my next document, I'm using a lot of that information. I was unable to find it again, just browsing for it on this Infosys. So I don't know. In any case, so yep, that's pretty much it for today. I'm going to go ahead and shut this down. And Phil, you and I can talk a little bit offline after this, but thanks everybody, and check it out on YouTube. And if you're interested, check out the Automation Academy on automationllc.com. Thanks a lot.